Myself Vijay Lakshmi. Today we are discussing about AIML subject. Problem statement is evaluate and comparing the performance of two machine learning models using the statistical metrics. My team members are Aishwarya, Preeti, Sahana SU, Sahana RC. Introduction. Evaluate and comparing the machine learning models is essential to ensure that they perform well real world tasks. Statistical metrics provide objective ways to measure the model's accuracy and reliability. For classification tasks, metrics like accuracy, precision, recall, and F1 score and ROC and AUC show how well the model predicted different categories. For a regression task, metrics such as MAE, MSE, RMSE, and R square score qualify how the close prediction are actual values. By using these metrics, we can systematically compare the models, identify the best performing one, and make an informed decision for model selection and improvement. Statement. Best machine learning model can be difficult. This project compared two models using statistical metrics to determine which one is more accurate and reliable. Next part will be continued by Preeti.
Vijay Lakshmi, and the key matrices. This slide will be the first one is MAE, means mean absolute error, the average of the absolute difference between the prediction and actual values. And next will be the MSE, mean square error, the average of the square difference between the prediction and actual values. And next RMSE, that means root mean square error, the square root of the MSC, which is the original units of the data. And next R square score, um, a measure of the proposition of the variance in the dependent variable, that is the predictable from the independent variable. And next slide will be the evaluation process. In this slide will be the collection of the pre-processed data. That means to collect the data that involves the cleaning and normalizing and splitting the data into training and testing sets. And next step will be the train models. Both machine learning models are trained and using the same data. And next will be the make prediction. The trained models are used to predict the outcomes on the test data. Next will be the calculating matrix, statistical and matrix, which is the accuracy, precision, recall, FN score, and MAE and RMSE are the computed. And step 5 will be the compare performance. The calculate the matrix and analyze the identify the better performance model. Next step will be the visualization result. Tables, graphs, or charts are used to clear the present of the compare the performance of the models. And this is the evaluation performance. And next will be the continued by Sahana Chavan.
So I am continuing the challenges. Ha- Handling noisy, incomplete, and imbalanced data. It means clean and a balanced data to provide a bias and a error-free model predictions. Selecting appropriate statistical metrics for fair comparison. It means we have to choose the right valuation metrics um, based on the problem and the data type. So avoiding overfitting and underfitting during model training, use technique like cross validation or a regularization to ensure the model learning just to uh, just not too enough or too much or too little. Ensure model generalize well to unseen data. It means we have to test on a new data to confirm the model work beyond. And managing computational resource and a training time for a large data set, it means we have to optimize code, use efficient algorithms, or we have to apply hardware acceleration to handle big data. Next, comparison. Comparison of a models. Here we have matrix, model A, model B, and we have better model. So we have accuracy 88% for model A and for model B 91. So the accuracy is more or the higher in model B. And we have precision. So we have in model A we have 85%, model B we have 90%. So here the precision is more in a model B. Recall we have 87% and 89% model B. So here we have 89%. So better model is model B. F1 score 86% in model A and 89% in a model B. Of course, the better model is model B. RMSC or a MAE if regression 0.3, 0.2. Here we have considered model B as the best or a better model. Next slide will be continued by Sahana.
Thank you, Sahana. Now I'll explain about conclusion part. Evaluating machine learning models using statistical metrics provides an objective way to measure how well they perform. Metrics such as accuracy, precision, recall, and F1 score help quantify a model's ability to make correct prediction, handle imbalanced data, and balance false positive and false negative. It compares a model showing high values across these metrics is generally more reliable and effective for a given dataset. Proper data processing, including cleaning and normalization, ensures that these metrics reflect true performance while selecting the right metrics and using visualization
ಹಿಂಗ್
like
ಮಾಡಬೇಡ ಇರೇ ಲೈಕ್
confusion
ನೋಟಿಫಿಕೇಶನ್
matrix or
ಸೌಂಡ್ ಬರ್ತಾ
arrow
ಐತೆ.
seekers help interprets result clearly. Overall, statistical evaluation is essential for identifying the most suitable model and ensuring accurate and robust prediction. And next part of the code will be continued by Aishwarya.
Thank you, Sahana. This code compares a logistic regression and a random forest and the breast cancer dataset. First code will explains which stores the loads and build the breast cancer dataset, and the second which is used to split the data into training and the testing sets, which scales a normalization and the futures for a better performance models. And the next code will tells about the import between the logistic regression and the model, which imports the random forest models, and these imports matrices for evaluating model accuracy and performance, which can be set the dataset in x and y labels. Uh, it splits the data in 80% training testing and maintaining the class balance, which is used to create the scalar object to normalize the data. Evaluating performance, which evaluate the training and the logistic regression models, which predicts the classes labels and probability to test the data, which is having the trained random forest and model and evaluating the predicts class based on the probability and test. Here the confusion, precision, recall and F1 ROC AUC, which is used for the display the evaluation results. Here we can see the matrices which we are having the logistic regression and the random forest, which prints the models having the basis on the evaluating the models. This logistic regression and the random forest both models performs well, but random forest usually gives a slightly better accuracy than we comparing the logistic regression. Here we can see the higher ROC and the AUC showing stronger overall performance. By this method we can see the ROC showing overall high performance than the random forest. We can easily predict the accuracy having a high precision like a ROC and a random forest. Thank you.